Hello everyone. So welcome to today's lesson on Java multithreading. If you have ever wondered how Java handles multiple tasks at the same time or how memory is managed when multiple threads are involved, you are in the right place. So let me tell you what is process. A process is an independent program in execution. Then what is program? So let's say we have a demo program or hello world program. And let's say helloworld.java is the file name of this program. Now I am giving a command java c helloworld.java. It will convert the helloworld.java into helloworld.class file. Now when I'll give command java hello world, it will create a JVM process, and JVM process will create a main thread. So each process will have at least one thread, and that will be the main thread. Okay. Now let me show you this example. So I have hello world program, and if I run this program, you can see that thread is started, and that is main thread. So this is the main thread. Okay. Inside main method, there will always be a thread, that is main thread. So it is started, and then I am printing hello world, and then it's completed. JVM creates this main thread. Now, so as I have mentioned, process is an independent program in execution. It includes everything like memory, variable, system resources, execution state. And in an operating system, each process runs its own isolated memory space, separate from other process. Like let's say we have two different processes. Each of them has their separate memory, separate threads. I'll talk about thread in a later section. But let's say whatever is required to run the process, everything is associated with the process itself. We do not share with other processes. For example, let's say if you open a Google Chrome and Microsoft Word, both of them are separate process. Each of them run as a separate process. They do not share resources with each other. What is thread? So a thread is the smallest unit of execution in program. In Java, threads are lightweight subprocesses. So a process can have multiple threads inside, and each thread can run different, it's a small part of the program. When multiple thread run in parallel, it's called multithreading. So let me show you this diagram. So here, this is the program, and we have multiple thread. And once all the thread completes this execution, our main thread execution will be completed. So let me show you an example here. I have created a thread. So this is my thread. Okay. So inside main, when I'll run this program, you can see the first thread is the main thread. Okay, so this one is the main thread. Now I'm creating two other threads. Okay. Now if I run this program, you can see here, first is main thread, and then I have started this T1. So it is printing like thread 0. And then thread 1 is created, and at last you can see the main thread. After completing these two threads, main thread is running. So once it is done, so once we come out of main thread or main method, so JVM will exit here. So let me show you what are all resources are present inside a process. So each process will have a separate heap memory, and each process will have separate threads, and each thread share this memory, and this is the code section and data section. In code section will have all the instruction that is mentioned in the code, and data section will have global variables. And this register, stack, counter, all these are part of a thread. So each thread will have a separate register, stack, and counter. So what are the functionality of all these resources and memory? So first, heap memory. So this is a shared among all. It stores objects and class level data. If two threads access the same object in the heap, you need synchronization to avoid data inconsistency. Then each thread will have a separate stack memory, which store method calls, local variables, and as I have mentioned, this is not shared with other threads. So it's thread safe. So stack is thread safe. Heap is not thread safe. So we need synchronization for heap. Okay. Now, next is program counter. Let's say we have a program var a comma b, and then a equal to 10, b equal to 20, sum equal to a plus b, right, and then print sum. Okay, so this is the program we have. So program counter is basically it execute the instruction like this. So it store this address. Let's say this address is 1000, then this address is like this. So here now PC program counter is pointing to this instruction. So PC will be 1000. Next, when program counter will go in this instruction, PC will be 1002. So like that. So program counter, it helps thread to execute each instruction one by one. Okay. Now registers, what it does. So Java does not expose registers directly, but at the OS level, their threads might use CPU registers. So a process can have heap memory, it can have a shared resource like code instruction, it will have data section, it will have, and then register, stack, counter, right? And this all are part of a thread. This is a separate thread, this is another thread, and this is another thread. So they do not, each thread do not share registers, stack, or counters. All of these threads share the code resources and heap memory. So that's why these are not thread safe. We need synchronization. But for stack, counter, register, we do not need any synchronization. They are thread safe. Okay. So what are the benefits of multithreading? Better CPU utilization. Let's say we have 4 or 8 core CPUs. We can run the program in parallel, so it will help in it will run smoothly, and also it will run faster. So for faster execution, better CPU utilization, and responsive UI. It keeps apps smooth and interactive. So real world apps like gaming apps, they need multithreading. So what are the challenges of multithreading? Complex debugging. So very hard to debug. Race condition can come, deadlock can come. So in summary, threads are lightweight unit of a process, and JVM gives each thread a separate stack, register, program counter. Understanding memory allocation help in writing thread safe code. So if we are accessing heap memory, then we need synchronization if there are multiple threads available. And we use multi-threading to improve performance. But there are few disadvantages as well that we have mentioned. So that's it from this video. Please like, share and subscribe to my channel. Do not forget to click on the bell icon so that when I upload a new video, you'll get a notification.